Okay, so we're going to start off today with multiplication of polynomials, which is the next step into our polynomial unit. Well, let's start off with an example here. Let's say we have 3x squared multiplied times x cubed plus 4. Now, if you guys do not, let me rewrite this. If you guys do not remember your exponent rules, it would be nice for you to go back and look at my pre-algebra playlist and watch our exponent rules so that you guys will know how to properly use these problems. Plus 4. Okay, I'll do a quick overview here, but I'll do a quick overview here of the exponent powers, okay, when you're multiplying. It says if we have a to the m power multiplied times a to the b power, this would be equal to a to the m plus b, okay? What this is saying here is that if you have the same base, then you can add the powers. When you're multiplying and you have the same base, all you would have to do is add powers. Let me give you one more example here. If we take 3 to the 4th power multiplied times 3 to the 5th power, we'll have 3 to the 9th power because this is the 4 plus 5, okay? All right, with that being said, let's go ahead and get started with this multiplication of polynomials here. Well, what I'm going to do, I'm going to distribute this first number, this monomial here, to this binomial that's inside parentheses, of course. All right. Now, so what I'll have here, I'll have 3x squared times x cubed plus 3x squared times 4. Now let's see, these two, they do have the same base because this x is being squared and this this x is being cubed and this x is being squared. So I can add my powers here. So I'll multiply my constants, but I'll add my powers. Now you know it's a 1 in front of that x cubed. So I'll have 3 times 1, which is 3. And then this is x squared times x cubed. Well, we add powers. This will be x to the 5th. So I have here 3x to the 5th power. Now, with this over here, I don't have any variables on this 4. I just have the constant term 4. So I multiply 4 times 3, and then I'll get 12. So it'll be plus 12. And then, of course, I bring down my, my variable part, which will be x squared. So I have 3x to the 5th. Plus 12x squared. And this is the product of this monomial times this binomial here. Now, of course, these problems are going to get more lengthy, and I'm going to show you more shortcuts that you can work with these problems, okay? This was just a quick introduction, a quick refresher problem. Let's get a little bit more intense here. Let's say we have x minus 2. Let's see if we get a barrier here. Let's see if we have x minus 2 multiplied times 1 plus 3x minus x squared. 1 plus 3x minus x squared. Make sure this problem's right. Yeah. So what we're going to do, basically, we're going to distribute everything that's in here to everything that's in here. Okay? So basically what this is saying, this will be, let's make this a little bit easier so we don't have to rearrange it after we distribute. Let's put this in standard form here. Let's go ahead and put this in standard form. So in standard form, that problem would be minus x squared plus 3x plus 1. Okay, that way when we multiply, it'll automatically come out in standard form. All right, so let's get started here. So we'll take this first term here times everything in parentheses. Okay? And we're going to subtract it from, and it's going to be subtracted by this -2 multiplied times everything in parentheses. Okay? Well, with that being said, let's get started. We have x times minus x squared. Okay, now plus this x times this 3x plus, because the sign on this x is positive, so I'm going to put a positive sign here. So x times this positive 1. And then now remember, we're subtracting this next. We're subtracting -2 times a minus x squared, I'm sorry. And then this -2 times this plus 3x. And then this -2 times this positive 1. Okay, so what do I have here? I have this x times this minus x squared. Well, they have the same base, and this is a power of 1. This is a power of 2. When I multiply, I'll take the same. I'll add the powers. So 1 plus 2, which will give me a minus x to the third power, because 1 plus 2 is 3. And then I multiply this -1 in front of here times this 1 and get a -1 down here. All right. This will be plus x times 3x. Well, x has a power of 1. 3x, that has a power of 1. I add the powers, multiply the constants, so that's 3 to a power of 2. So 3x squared. Now, here, x times 1, of course, is just x. Okay? Then now I'm subtracting. Well, let's look here. This is a -2 times a minus x squared. So I know this is a -2 times a 1 times a -1, which will give me a positive 2. And then this, let's see, we're going to bring down this x squared because 2 has no x squared on it or anything, any exponents or variables of x. So now we have a -2 times this positive 3, which will give me a -6. Now, what variable do we have? Well, we just bring down the x. Now, this is a -2 times this -1, which will give me what? Well, that indeed is a -2. Now, let's go ahead and combine our like terms here. Let's combine them. We have this x cubed, no other x cubed, so I'm left with x cubed out up front. Now let's see, powers of 2. Well, we have 3x squared and we have 2x squared. 3x squared plus 2x squared, I'll take 5x squared. Because I'm adding them, since I'm adding them, I'm taking these variables back here and their exponents as like terms, okay? So we're done with that, we're done with that, and we're done with that. Now let's get the powers of 1. Well, I have a -6x and I have a plus x. So x minus 6x, well, this will give us a minus, make sure we indicate that, a minus 5x. Okay? And that's minus 5x. And let's see, we're done with that and we're done with that. I just bring down this -2. And for my final product of minus x cubed plus 5x squared minus 5x minus 2. Okay? And this is the, beginning introduction to multiplying polynomials. Now, I will show you a method that we can use for multiplication to where it's not so much hassle and making sure we keep making sure we have the same signs and everything. Okay, this looks kind of like a lot, especially if you have a polynomial here and then a polynomial here, more than 4 terms here and more than 4 terms here. This method here can get a little messy. So I'm going to show you another method we can use, which is called the box method. Okay, the box method. Well, or you can call them the table method, which you'll hear it also called. Let's say we want to find the product here of x squared plus 3x minus 5 multiply times x squared minus x plus 1. Okay? Well, this is a 3 terms here, 3 terms here, and 3 terms here. So this is a trinomial times a trinomial. So I'll have a 3 by 3 rectangular shaped box here. So I need 1, 2, 3, and then 1, 2, 3. Okay. Now, what I'm going to do, I'm going to put this polynomial here at the top, and then this polynomial here vertically here. So let's put it here. Let's put x squared And then make sure you put the sign with it, positive 3x minus 5. And then down here will be x squared minus x plus 1. Now, if you do not put the signs, it will mess you up as far as when you're doing your computation. You're multiplying here. So what will we do here? Well, let's multiply this term times this, and we're going to put it here. And then this term times this, and we're going to put it here. Then this term times this, and we're going to put it here. Then we go to the next row. This negative x times this x squared, and it'll go in this box. This negative x times this positive 3x, and it'll go in this box. I think you get the hang of it, okay? So let's go ahead and do that. This x squared times x squared, well, this will be x. This will be x to the 2 plus 2, which will be x to the 4th. Then x squared times 3x will give us 3. And then x to the 1st times x to the 2nd, which will be x to the 3rd. Then let's see, what are we dealing with next? Let's see, this x squared times this minus 5, well, it'll be minus 5x squared. And then this minus x times this x squared, that'll give me a minus x cubed. And then let's go to the next. Let's see, this is a minus x times this positive 3x, which will give me a minus 3x squared, because I'm adding the powers, of course. And then this is a minus x times this positive 5. I will get a positive 5x. Okay? Now, let's move to this one. This is a positive 1 times this x squared here. And what will we get? Well, we'll get x squared. Then this positive 1 times this 3x, we'll get 3x. Then this positive 1 times this minus 5, we'll get a minus 5. Perfect. This is a lot more neater than this problem up here to where we did all this work out. A lot neater. Now, what can we do with all this information? You say, hey, this is just numbers in boxes. Well, what do we do with all this? Well, I'm going to show you now. Let's start off with the highest power. Let's start off with the highest power. Let's find it. What is the highest power here? It's 4. And I'm going to take it and I'm going to see if there's another power of 4 I can combine it with. And there's not. So I'm going to have x to the 4th. And then I'm going to add it to the rest of this stuff here. But x to the 4th is done, so I cross that box out. Now I'm looking for powers of 3. Well, I have a power of 3 here, I have a power of 3 here, and nowhere else. So this will be 3x cubed minus x cubed, which is basically 3 minus 1, which will give us a positive 2x cubed. And I'm done with these boxes here. Now I'm going to my squares. Let's see. We have a square here, and a square here. Okay? Now, we have x squared minus 3x squared minus 5x squared. Well, minus 3x squared minus 5x squared, that'll give me a minus 8x squared. And if I add it to this 1x squared, I should get a minus 7x squared. I should get a minus 7x squared. So minus 7x squared. And this this diagonal row is gone. As you can see, I'm going to diagonal row. That's exactly what I'm doing. Now let's look here. Let's look for our powers of 1. I have a 3x here and a 5x here. Since there's no sign that I didn't write, we're assuming that they're positive. So then we'll just combine these. We'll multiply these. A 3x times 3x plus 5x, which will give us a plus 8x. Okay, and then I'm done with that row. Let's just go ahead and get my last constant term, which is 5 left. Cross it out because I bring it down here. So overall, I have x to the 4th plus 2x cubed minus 7x squared plus 8x minus 5. And this here is the product of these two trinomials up above here. Now, as you can see, this method is a lot neater than this method up here. You can get lost in what you're multiplying, what sign goes with what. You see, this box method, I use it a lot. It's very useful. It comes in handy when you're doing long polynomials like the one we'll see in this next example here. Okay, so go ahead and take a minute, pause the video, write it down, do whatever you need to do, and we'll move on to our next polynomial. Okay, let's go ahead and take this example here. This is not a long example, but I want you guys to be able to know how to do it here. Let's take, well, let me make up one off the top of my head here. Let's take x cubed plus 3x squared. Actually, no, that's not one. Let's take 4x to the fourth plus 3x cubed minus 16x squared plus x minus 15. Okay? And we're going to multiply this by 3x to the fourth plus 3x. Actually, we're going to multiply this by, yeah, well, let's go ahead and do that. 3x to the fourth minus 3x cubed plus 22x squared minus 14x minus 2. Okay? Now, whoa, this is a large polynomial here. This is actually the true definition of what a polynomial is. It has 4 more terms. Okay? What we've been dealing with before have been monomials, binomials, and trinomials. Now, let's look at this here. If we were going to use our old-fashioned method, we'd have to take this number distributed to everything in here, then this number distributed to everything in here, then this number distributed to everything in here, this number distributed to everything in here, and then this number distributed to everything in there. It's a lot. We have 4x to the fourth times 3x to the fourth, and then we have to do all of this, and then we have to do it again for 3x cubed. As you can see, it's a lot. Well, let's use our box method. We have 4 terms here, 1, 2, 3, 4. I'm sorry, we have 5 terms here, and then we have 5 terms here, 1, 2, 3, 4, 5. So let's go ahead and make a 5 by 5 box here. Let's make sure we have enough room here for when we're going to multiply this. Not the best box here, but it serves its purpose. Okay, so let's draw a line. 1 here, space is 3, 1, 2, 3 here. Let's make sure we have enough room. I can actually make these here a little bit bigger. Let me pause the video and let me go ahead and finish this off here. Okay, now that I have these boxes here, drawn this 5 by 5 rectangular box here, let's insert these polynomials here. Well, let's put this first polynomial up here. And remember, we're going to put its sign with it, so we know how what the sign of our product will be. And then this polynomial, let's put it here. 3x to the fourth minus 3x cubed plus 22x squared minus 14x minus 2. Okay, well, we can see that this box has already come in handy because we don't have a whole lot of parentheses and everything everywhere multiplying this and this. Okay, let's go ahead and get started with this. This 3 here, let's write in this 3x to the fourth times this 4x to the fourth, this will give me a 12. This pen here is, give me a second, let me, oops. This will give me a 12x to the 8th power, because I add the powers, of course. And then this 3 times this 3x, this 3x to the 4 times this 3x cubed, this will give me 9x to the 7th. Then this 3 times this negative 16, 3 times 16, that'll give me 48, so this will be a negative 48 with the power of x to the 6th. Okay? Then I'm dealing with 3x to the 4th times x, 3x to the 4th times x, which will give me a 3x to the 5th. And then 3x to the 4th times this minus 15. Well, 3 times 15 will simply give me 45, and this will be a minus 45. This will be minus 45x to the 4th. Okay? Now, let's do this row. This will be, I'm going to go ahead, if you guys know how to do this, I'm going to go ahead and fill this chart out here to save some time. Okay, now that I have this chart here filled out, let's go ahead and finish out our operations. Now this chart is really neat as far as compare it to our other friend up here where we had to do all this multiplication out. This chart, as you can see, is really coming in handy. Now let's go ahead and move down a little bit and let's start to combine our like terms. Well, we have 12x to the 8th. There's no other x to the 8th power, so we'll just have 12x to the 8th. And then that will be done. Now let's look at our 7th row here. We have a minus 12, and it's going to be plus 9, which we're dealing with the minus 3. Let's see, x to the 7th. Okay, now let's look at, now we're done with this 7th row here. Let's go to the 6th degree powers. We're dealing with 88 minus 9 minus 48, and we should get a 31. So positive 31, x to the 6th. Done with that. Now let's look at the 5th here. We're dealing with the minus 56 plus 66 plus 48 plus 3, and we should get a 61. Let's see, plus 61 x to the 5th. So we're done with this row here. Let's look at this next row here, the 4ths. Now let's see, we have minus 8 plus 42 minus 352 minus 3 minus 45. We should get a minus 366 x to the 4th. Cross that out. Now let's look at our 3rd degree powers, which is this row here. Okay. Give me a second. So let's look at this. So we'll have, okay, now make sure let's go ahead and change this real quick. This is supposed to be 45x cubed. Sorry about that, 45x cubed. Now, so let's go ahead and finish doing what we're doing. Let's take a minus 6 plus 224 plus 22 plus 45, and we should get a 285, a positive 285x cubed. So we're done with this row. Now let's go down and let's see this square powers, the powers of 2. Well, we have 32, we have minus 14, minus 330, and we're going to get a minus 312 x to the square powers. Minus 312x squared. Let's make that noticeable. We're running out of space here, so let's cross out that row. And now we're dealing with a negative 2 plus 210, and we're going to get a 208. I'm gonna run out of space. We're just gonna put it down here, 208, and then it's gonna be an x. We're done with that, and bring down our constant of 30. Okay. Now I'm going to rewrite this answer here in the white color here. So 12x to the 8th minus 3x to the 7th plus 31x to the 6th plus 61x to the 5th minus 366x to the 4th plus 285x cubed minus 312x squared plus 208x plus 30. Now the reason we have so many big numbers here is because like I said, I made this problem off the top of my head, so we would have some pretty large numbers here. But this is the product of these two here, polynomials. Okay? Take a minute, pause the video, write it down. Great steps here for multiplication of polynomials.